Ladies and gents, hello and welcome. It is the 2018 paper and we are doing the short questions. My name is Mr. Claffey. So, like the way I teach, these questions are going to be done with question, important related topic, possible solutions, final answer. So you're going to get a lot more than just the answer, which should help you with the other years. And nice inspiring quote for you. Change is the law of life, and those who look only to the past or the present are certain to miss the future. JFK, back when he was launching the moon race. Section A, answer any 12 questions, but now it's 15. Why? Because they only use the best 12 and there's no negative marking, so what have you got to lose? So, question 1A, the impact of technological development over the past century has revolutionized the way we work. How have assembly line productions impacted the world? So, assembly lines are what we see on the right there, and they have revolutionized the world since Henry Ford came along, taking his idea from a butcher's with his car system, which makes it faster, standardized, and can use unskilled labor. And now we can use robotics way easier. So as you can see, the unskilled labor in the top left and the robots in the right. Computer aided manufacture, CAM, and this is highly accurate and improved production standards and speed. So the only downfall is it costs a lot of money, which a question comes up like that in other years. One, energy conversion taking place when a solenoid activates. So as we can see, a magnetic field, and it is changing electrical to magnetic, and then we can go magnetic to kinetic. So your electricity passes through the pole and creates an electric field. And describe an operation of a solenoid. An electric current through the coil creates a magnetic field. And some of you may have done that experiment in science with the pins. When you pass electricity through it makes that shape. So, looking at the shape then, the field exerts a force on the magnet which we can use to cause pistons to move up and down. Okay, biometric software systems such as facial recognition are used in modern applications. Suggest one use of facial recognition. Retail marketing. So you can actually target the individual directly as soon as they walk in the store, like your Amazon Go stores. So security, you can gain access to buildings and locations through your face, or even just go for unlocking your phone with your biometric facial ID. And authentication, passport control, which they already use to a degree if you have that little picture of a camera on your passport, and access to buildings again. So calculate the power output of a solar motor. Well, we can get the power equals voltage by current from our log tables. Okay, so power equals V, which is 12 volts multiplied by 30 milliamps. Now the problem with milliamps is we need to convert that to amps. So when we see the word milli, we divide by 1,000 to bring it into its form of amps, and then just multiply out the answer, 0.6, and it's in watts, which is the unit of power. Two safety features into power, such as bandsaws. So I'm going to answer this as if it's in every single machine, because this applies to most machines. So look at that big red button that is on most of the dangerous machines in the room, and it's an emergency stop button. Every single student should be familiar with the emergency stop button, which is on all machines. Second is the adjustable guard. So over every single blade on most machines there is a guard which you can adjust up and down. And 110 volt power supply. That's a bit trickier, but you could see that from those yellow transformer boxes. So calculate the total resistance. So resistors in parallel, well, they look like parallel lines, which kind of helps. And there is a formula in the log table. So the formula for resistors in parallel is 1 over RT equals 1 over R1 plus 1 over R2. Sorry, you didn't write that down. And kilo, when we see kilo, K, we multiply by 1,000. So when you see milli, divide by 1,000. When you see kilo, multiply by 1,000. That is just a general rule, but it usually works in technology. And here we have 1 over 2,000 plus 1 over 3,000. Throw that into your calculator and you should come out with 1,200 ohms, which is the unit for resistance. And now we need to get in series. So 500 plus 1,200 is 1,700. And that formula is in the log table as far as I know for series as well. State 2 features of the gearbox shown, which facilitate a smooth transmission of power and minimal noise. So, use of bearings offer minimal noise and wear and tear. So, bearings are always coming up in the paper. Use of lubricants. Example, oil, brine, graphite. And feature 3 for good measures. The shape of the gears are helical gears. So they're all at an angle, which reduces wear and tear as well. So some of the most common cybersecurity risks are socially engineered malware, phishing attacks, and unpatched software. Explain any 2 of these terms. Of course, you're going to do 3. Socially engineered malware. So winner, as you can see, stop trying to click it, is an attack that tricks the users into clicking and installing malicious software. So mal meaning bad, Latin for bad, and once you download that software, it compromises your computer system. So you've probably seen them before, especially your grandparents would have been clicking them like mad. Win an iPad Nano back in the day. So I don't know if any of you would remember what an iPad Nano is. Very unlikely. So just Googling the Nigerian prince. The mastermind who claimed to be the Nigerian prince was finally arrested. And your parents would have more than likely got emails from this Nigerian prince claiming he had a vast sum of money and he was going to share it with us if we could just give him his bank account details, give us the bank account details, username, and maybe even a credit card detail, and you would give him €10 and he would give you thousands. So attempting to gain sensitive information, username, bank details, credit cards by targeting content relevant to the user. So the relevant content was obviously who didn't want to be very, very wealthy by just giving a tenner to this Nigerian prince, or so we thought. Unpatched software. So operating systems and software develop some vulnerabilities over time from people kind of figuring out glitches in the system and figuring out how to take advantage of those glitches or mistakes. So these are usually rectified with patches, because obviously companies like Microsoft and Google want to keep their stuff without having any vulnerabilities. However, companies like Microsoft may have unpatched systems because it has ran out of protection, like the out-of-date Windows 98, and they can't afford to keep covering it. Explain the following terms. Those monomers are all molecules, single molecules, and when they are bonded together, they become a polymer. So, a monomer is a molecule that can be bonded to other molecules to form a polymer. As we see in the picture, numerous single monomers, and they're all chained after polymerization to become a polymer. Brittleness. So this is actually a test for brittleness, is pulling apart metal. And as you can see, the different ways the metal can break, and the property of a material which causes it to break without deformation, which is this first one here and the second one where they're both deformed. The last one is just shattered. So, a property of a material which causes it to break without deformation. Important side note, this can be related to the exposure of UV light, like those sun chairs left out in the light. Upcycling. So, Busy Bees, an Irish retail company specialising in upcycling. What is upcycling? So it is taking an old product and making it into something better, basically. So here we have like the front of a car and they've turned it into a bench. And we have a bicycle and they've turned it into a table. So the exact term of upcycling, the process of transforming used materials or products into better quality products with improved use or usability. So there's no point in getting an old product if you're just going to make it worse. You're meant to get an old product and then transform it into something that is even better. So carbon neutral. So what is carbon? It contributes to pollution in our atmosphere, and we are trying to neutralize it. So the aim of balancing carbon, CO2, emitted into the atmosphere with actions that reduce or offset. These culminate in zero carbon emissions. So if you're making a building, you have to plant a few trees or use better processes. Shaft and ratchet wheel. So you just saw how it works there in the way it was spinning. And this comes up every year, so I would definitely put a star beside this. And it usually asks how it works and to label it. So name the mechanism shown at A. Well, it's a ratchet and pawl. So the wheel is the ratchet and the pawl is the little lever, and we can see it working again there. And how does C operate? So C is a cam and it rotates, and the cam rotates and pushes this link up and down. So as we can see, the cam C rotates, and as it rotates, the follower linkage gets pushed up and down. So we're going to call this B. Linkage B gets pushed up and down. Anything on top of a cam is called a follower, by the way. So it will raise and lower every time it goes into that slot, and that releases the pawl, and then the wheel can then move anti-clockwise. So probably more detail than was required, but perfect for understanding all the same. Okay, so on to the next question. Question 12. Log tables. First thing I do, go to the log tables, find the equation for potential energy, which is mass, gravity, and height, and manipulate it to what we need. So if you're not sure how to manipulate it, well, you could always find all of those and input the formula regardless, and then manipulate it after. However, it might be handy to remember H equals potential energy over mass by gravity, and vertical distance, also known as height. So the mass is 65 kg, and the gravity is 9.81. Potential energy is given to us because they are just that nice. And all we have to do is input all of this info into the formula, calculate it out, and that is our job done. So 7,014.15 and multiply by 65, and gravity on Earth is usually 9.81, even though I've been told it can change slightly ever so often, but a physicist will have to correct me on that if I'm right or wrong. The alternative is work equals force by distance, but that was the method that I used there. So sketch any two orthographic views of this integrated chip circuit shown. Well, what I'm going to do is teach you an extra question that comes up every year. So that notch in the corner here indicates the leg position. So it goes anti-clockwise from the notch 1, 2, 3, 4, 5, 6, 7, 8. Orthographic views. This comes up every single year as question 13. Know your plan, elevation and end view. And ideally put them in the right order. So this chip is also used in children's toys to move or make noise, as a side note, because that comes up as a different question in other years. So 555 timer always comes up. Know how to draw it in terms of 2D. So here we have me as a little stick man looking in directly on it. So everything's going to be 2D. So I'm going to draw my 4 legs to start with, and this could be any size in terms of, like, everything should be in proportion, of course, but like there is no dimensions or sizes given to us. So what I'm trying to do is draw it as close as I can. That little dot is hidden detail, and this part is unnecessary where I shade it in, but it looks nice for the example given. Now here we have my plan view. We are looking directly down, as the Fortnite gamers call it, the bird's eye view. So we're looking directly over it, and this part here, we take the same width that we drew in elevation. We go down any distance and find a center line. Then find another center line just to make things easy for yourself. So here's me drawing it in. A little bit easier for me because once I draw the rectangle it auto corrects. So I have my box, I'm putting in my notch and my other circular notch there, and writing down those words and putting in the legs. Now the legs should line up ideally, or very, very close, and then I just number them just for the sake of showing off, to be honest. So that was that there, and moving on to question 14. So reduce the rotational speed. Once you read the word reduce rotational speed, we are thinking of something slow, a gear that is slow, a worm gear. So a mechanism to reduce rotational speed. And you know, that looks complicated, but if we just read the word reduce rotational speed, we're thinking of a worm wheel and worm. So I'll just get a picture of the worm wheel and gear, and that is what's going on inside the box. So we can see that it is a worm wheel and gear. You would obviously have to be a little bit more familiar with them to recognize that that's what's hidden inside the box. A function of key and groove shown in input shaft A. Well, if you have a key on a circular groove, it's less likely to slip. The key sits in the groove for greater traction. So it's like the motors and the wheels as well. Everyone that's familiar with the yellow motors, they just sit onto the gears. Two techniques to enhance the graphic representation of the fire extinguisher. Like, this is a question just to show off. Shade the ground. Every single person knows how to shade the ground. Bring colour to your exam. And then number 3 is kind of indicate any glass or reflection with those symbols. And that is like a basic version of what you need to do. I'm just doing this on the iPad, which is a hell of a lot harder, believe it or not, for drawing out these things. But I'll make a first stab at it. There's my little reflection symbol. I like to darken one of the edges and brighten the middle, or darken both edges and brighten the middle, depending on the object. And there's my glass. It's way easier to do. 4, actually, darken any area of depth. So any area where you think, do you know what, I've seen this object in real life and it looks very, very dark in those areas, like the inside of a fire extinguisher or the back of a fire extinguisher. And then I just add my colour, because you know what, life's better with a bit of colour. Thanks for watching, and I hope this was informative. Any extra information in those questions, I usually attempt to have them covering other years. So just in case you think I'm waffling on, I usually amn't. However, occasionally I do get distracted.